Hello and welcome to this three-part series looking at getting into scanning. The first presentation, this one, will be covering scanning for beginners. This is the basics of general scanning where we will just look at terminology and some of the things to consider when looking at scanning. The next part, or part two, will be looking at scanning best practices where we'll cover field considerations for a successful scanning project. And the third part will be looking at office workflows, highlighting some of the office capabilities for scanning. The practices discussed throughout this presentation are all relevant to all scanning projects and manufacturers in general. However, we will be looking specifically at Trimble scanners and software as they will be what will be referenced throughout this presentation. So, part one, scanning for beginners. To start with, let's look at some of the scanning terminology. We'll start off with a point cloud, which is a set of points in 3D space. This is essentially what's collected from the scanner, and it's called a point cloud because it looks generally like a cloud of data. Stations are where a point cloud is collected from. So this is the setup location where the scanner was set up. A scan is a combination of the point cloud and the station, and a scan will produce a point cloud. Registration is how two scans are joined together and positioned in 3D space. This can be done automatically or manually, and there are a couple of different ways that registration can be done. Registration sets are when multiple registered scans are joined together. You can have multiple registration sets within a project, and a good example of this would be outside, would be one registration set where you join all the outside scans together, and inside on the ground floor would be another registration set, and maybe the first floor would be a third registration set within a project. Shadowing is what occurs in a scan when it can't see something behind an object. So scanning cannot measure through walls, trees, or anything like that. It can only measure what it can see. Shadowing is what looks like when you are scanning and you can see things behind the object where no data has been collected. Essentially, it looks like a torch has been shone out from the scan station. To overcome shadowing, you would want to change the scanner into the area that you want to capture the data and do a second scan to capture that area. Ghosting is an important consideration in scanning as it highlights areas of a scan where two scans don't join up together. It shows the mismatch, and errors will accumulate due to ghosting, and it's areas that should be looked at when checking for problems or just generally checking how two scans join together. Images are generally captured as a secondary process when scanning, and panoramas are generated from those images. Colorizing, or true color, is a secondary process as well. The scanner will initially set up and do its scan and measure a return of the signal. So it will be able to color the scan in some form, but that color is based on the strength of the return of the signal. The actual true color aspect is created in a scan by overlaying the point cloud against the image, and the pixel in the image where a point is overlaid is the color is applied to the point from the scan data. Leveled scans are when the scanner has been set up and the scanner has identified that it's within tolerance and it can identify a ground level. You can have unleveled scans, so if the scanner is out of its level tolerance, an unleveled scan will occur, and this will float in all axes, whereas a leveled scan generally knows where level is. Errors generally refer to the mismatch of scanning data. They can be small, as in millimeters, or large, as in meters. Most errors can be minimized through observing best practices in the field or post-processing techniques. Understanding the different types of registration is also important to understanding errors. Errors are not necessarily a massive problem within scanning. Generally, we're talking millimeters, and that is cloud-to-cloud based registration, which we will discuss moving forward. However, if you're seeing meters or other things within scan data, there's generally an indication that something else is going on, and all the scan data should be considered. We've talked before through already about different types of scan registration, and we'll take a bit more of a look at those now. So as I mentioned, registration looks how scans are joined together. Accuracies in scanning projects are dependent upon how well the registration has worked. Registration can be done in the office, or in newer scanners can be done in the field, where the process is joined together in the field and the office gets a registered set of data. Multiple registration techniques can be used in a single scanning project, and different registration techniques will give different results. To begin with, let's look at unregistered data. This is a scan without any association to any other scan data within that project. Generally, when a traditional scanner is set up, it measures every scan as being set up on 00. So for that reason, when you bring the data in, all those centroids of the scan data are going to be positioned on the same location, and it looks like a mess or a cloud, as can be seen here on the right. Scans won't have any orientation other than the direction that the scanner was set up when it was started. So there is no relevance or association to any other scans when you import unregistered data. For projects with more than one scan, registration will be needed to fit the data together and make it look like it is in the real world. An example of a scanner that will collect unregistered data is a TX6 or TX8, and the X7, when it isn't using perspective or you're just loading in the raw scan data, will look like unregistered data. The SX10 or SX12 can do this when using a scan station. Again, as there is no relevant information as to where the setup location is when using that instrument as a scan station, it doesn't know how to fit the scans together, so it will handle the data this way. Cloud-based registration is generally the first and the most common form of registration. It's the process of joining two scans to one another using an algorithm and common areas within two scans and fitting the data together. The registration can be done manually, or there are automatic processes in most software packages that allow it to try and match up. It's always worth noting, though, if you're relying on the algorithms to match the scans together in both field and office processes, to make sure that you check the data to ensure that there is no ghosting and the data matches up properly, as relying on the algorithm can sometimes cause problems. With cloud-based registration, small errors can creep into the registration process due to there being no fixed matching locations. Georeferencing can be done in cloud-based registration as a secondary process by shifting scan data locations to a known point. Large flat vertical surfaces will significantly help cloud-based registration. And it can also be difficult to achieve survey-grade accuracies through the cloud-based registration process. Later on in this presentation, we will take a bit more of a look at some of the things that are considerations when looking at cloud-based registration. For the field scanners, X7 Trimble scanners will do cloud-based registration with perspective, or unregistered data that has come into software packages such as TBC or Trimble RealWorks will allow the cloud-based registration process to occur to match the scans together and produce a valid result. Target-based registration is a process of using targets and spheres within the scans to align clouds together. This registration is done during post-processing and is done in the office generally. Targets need to be set up and picked up in the scans when it's done out in the field for this to work. The targets will also need to be located in multiple scans for them to match up and join to one another. You don't have to collect all the targets in a single scan, but it's generally recommended to collect at least 3 targets in each of the scans and have overlap between them. Spheres can also be used instead of a black and white target, and spheres are something that scanning uses to position scans to one another as a target. Registration and georeferencing can be done automatically as a single process where targets can be given a set of coordinates, and the whole process of registration and georeferencing can be done as a single step. Survey grade accuracies can be achieved through target-based registration. It's an office-based process done within the Trimble environment currently, and Trimble RealWorks will be the only software package that can do this in its workflow. Station-based registration is the process of using traditional survey practices to identify the location of the scanner. Scans are tied together using setup locations which are linked through traverses, and registration is done through the traverse and network adjustments, not through point clouds. In station-based registration, we aren't joining the scans to one another using the clouds, we're joining the scans to one another using their setup locations. Georeferencing is done through traditional practices in these occurrences, and survey grade accuracies are achieved using this process. Scanners that can be used for this process are things like the SX series within Trimble, used with Trimble Access in the field. Trimble Business Center and RealWorks can be used as office solutions for processing this data. However, it is worth noting that this is a field process, and the traverse network cannot be calculated in the office as a backwards compatibility. It needs to be done with a specific scanner that can handle this. There are a couple of considerations that need to be done when using different types of scanning. A mix of registration can, and in a lot of cases should, be used in a single project. So cloud-based registration can be used to do quick backfill between locations, and station-based setups can be done in certain areas to tie that cloud-based registration back to where it should be positioned. The type of registration process should be considered before starting out on a project. Different registration processes will have different outcomes and do need different amounts of data when being used in the field. No registration process is necessarily bad when considering all aspects of that process, and good results can be returned from all types of registrations. In general, it's best to consider the best type of registration for the process before going out into the field and making sure you have the correct instruments. In the three examples on the right, in the forested example, it's best to have target-based registration, as targets will be used to identify and tie the scans together. In a case of a forest, it's not easy for the scan data to be linked together using cloud-to-cloud based registration, as even though there are a lot of trees, it's hard for the algorithm to identify each individual tree, and because the tree is being captured from different sides, it looks different in each scan. In cases where there are large, flat, open projects, it's recommended to use target-based registration or station-based registration. As mentioned previously, cloud-based registration needs to have some form of vertical surface, and it's best processed when there's large, flat vertical surfaces like the side of a building. In cases where you are working in an open environment or even in a forested environment, it's recommended that targets or station-based registration is used. We'll specifically look at cloud-based registration here, as there are some things that need to be considered when looking at it in the field. As mentioned previously, cloud-based registration looks at two clouds and uses an algorithm to best fit the scans together. Cloud-based registration is impacted by the data within the cloud. There is no other way of tying the scans together outside of what has been captured. So for this reason, there is some considerations. Looking at the cases on the right here, we have A, B, and C. In case A, it is just two flat scans with limited vertical data, and in this situation, cloud-based registration may not work as well as other practices due to the fact that there is nothing to lock the scan into any particular axis when looking at tying it to another scan. In case B, you can see that there is one single face against a wall that has been considered, and this is better than case A, and the scan can be locked against one axis. However, there is still an axis that's free and it can slide through. Case C, or an internal scan, for example, where there are two axes that can lock the data lock the two scans together, is the best case for cloud-based registration. Now, it must be noted here that this is not essential, and when we're talking about errors here, we can be just talking about millimeters, but it is a consideration here. Another thing to consider with cloud-based registration is long linear projects and also loops. The closer the scans are to one another, the better the results, and trees and poles do not necessarily make for great vertical data for registration as they change depending on the angle. Any errors that are introduced into cloud-based registration will propagate through the length of the project. Therefore, if you're doing a long linear project, the longer the set of scans that are joined together in one group, the further the more error will accumulate, meaning that your first scan might be in its correct location, however, the last scan may be out. The process relies heavily on flat faces, as we've discussed previously, and it should be considered when doing long linear projects that cloud-based registration is not necessarily ideal. It can be used, however, but you would need to break the scan down into shorter sections. It's recommended to have tie points along those sections, and wherever possible to include some form of flat face to join the scans together as best they can along the process. It's generally also recommended that every about 8th scan is a leveled scan as a minimum. This will ensure that the scans are returned to some form of level throughout the process. You could start with a single scan and do 20 or 30 scans that are unleveled after the fact. However, that will mean that by the time you get to the end, due to the way that cloud-based registration works, you may not be at a leveled area. So it's recommended to make sure that you have some form of leveled scan as you go through. To achieve survey-grade accuracies, targets and other techniques such as station-based scanning will be needed to ensure that you are tying back to some form of datum. This is particularly the case for large, long projects, as has been mentioned. Thank you for listening to part 1 of this 3-part series. For more information on scanning projects or queries regarding scanners, please call our support line.